Welcome everyone to day 7. Page 52 and 53 is your homework. Remember, we stopped with problem sets for the year, so there is no problem set due tomorrow. So just the page 52 and 53 you have to do. Give this warm-up a try. So pause the video, do the warm-up. Once you hit play, a box will pop up for you to put in your answer, and we'll go through the work. So go ahead and pause it now. All right, so the angle that's formed when you have crisscrossing chords, so our 10x minus 15, is equal to 1/2 of the sum of the two arcs. So the arc it's opening up to, so this one here, our 12x plus 8, and the one that its vertical angle is opening up to, so the 5x minus 22. So the 10x minus 15 is equal to 1/2 of 12x plus 28 plus 5x minus 22. The opposite of multiplying by half is multiplying by 2. So I think the easiest thing to always do first is multiply both sides by 2. Remember to distribute the 2 through both things on the left. So we get 20x minus 30. The half times 2, those are gone. And then combine your like terms from the stuff in the parentheses. So we have 17x plus 6. We'll subtract the 17x over. That gives us 3x minus 30 equals 6. We can add the 30 over. That gives us 3x equals 36. And then divide by 3 to get x equals 12. Every time in this course that you solve for a value of x, reread the question to see if that's what you want or if you need to sub it back in. In this case, we wanted to just find the value of x, so that's it. Moving on to the homework. Angle 1's a central angle, so it's the same as the arc it opens up to, so 100. Angle 2 is an inscribed angle, so it's half the arc it opens up to, so 50. For angle 1, we're doing what we just did in the warm-up. Angle 1 will be equal to 1/2 the sum of the arc it's opening up to, the 140, and the arc its vertical angle is opening up to, the 50, so we end up getting 95. Angle 2 is outside the circle, so it's equal to 1/2 of the big arc it's opening up to minus the small arc it's opening up to, so half of the 140 minus 50, so you get 45 degrees. In 3, angle ABC is outside the circle, so we had 1/2 of our big arc it was opening up to minus the small arc, so 1/2 140 minus 80, so we get 30. So this was 30 here. Angle CAB, this one here, that's just inscribed, so it's half the arc it opens up to, so half the 80, so we get 40. Arc AB has to add to 360 with the 230, so 360 minus 230 gives us 130 for arc AB. And then for angle C is outside the circle, so you have 1/2, and you have the big arc minus the little arc, so that's half of 100, which gives you 50 degrees. Five is very similar to the warm-up. Our angle formed by the crisscrossing chords, the 132, is equal to 1/2 of the sum of those two arcs. Multiply both sides by 2, you get the 264. After you combine like terms, you had 215. Subtract that over and divide by 7, you get x equals 7, and that's just what they wanted, the value of x. Six, same thing as the warm-up and the last question. Eventually you get x equals 9. In 7, we've got arc CB is equal to arc ED. So we know this arc and this arc are the same. BC, BD, and EC are in the ratio of 2 to 1 to 4. So call BC 2x, call BD 2x, call EC 4x, but then ED you can call 2x because it's the same as CB. So those four arcs should add to 360 because they go all the way around the circle. That's where that equation on the top right comes from. You eventually get x is 40. Fill in the 40 for each of the x's, and you get 80 for CB, 40 for BD, 80 for ED, and then 160 for CE. Once you have all the arcs, you should be able to answer any question they throw at you. Angle BCF is an inscribed angle, so it's half of the 40 that it opens up to. Angle EDF is also inscribed, so it's half of the 160 that it opens up to, so 80. Angle CFE, that one right there, it's a crisscrossing chord, so it's equal to half the arc it opens up to, the 160, and the arc that its vertical angle opens up to, the 40, so we get 100. And then DEC, so if you start at D and go this way around to C, that's 80 plus 160, which is 240 degrees. All right, we're going to start on page 49. We're going to do today what I like to call big circle problems. Basically, we're given a bunch of information, and we're given a picture that has lots going on. Almost always what you want to do is find all the arcs to start, because if you can find the measures of the arcs, you can answer any question they throw at you. Now, some things to look out for in the question. Sometimes you'll be given ratios that will allow you to solve for something. Always be on the lookout for a diameter, because remember, diameter will cut the circle in half, and not recognizing that will sometimes cause you to be stuck. So we've got the accompanying finger. ABC is inscribed in O. All right, so the first big important thing is at the end of that first line, BT bisects angle CBA. We know angle bisector implies two congruent angles, so therefore this angle and this angle must be congruent. We've got a tangent. We've got a ratio as well. Angle BAC. BAC would be right here. We would call that 2x. CBA, which is the big angle here, we're calling 3x. And ACB, which is here, is called 4x. Well, notice those are the three angles in the triangle ABC. We know angles in a triangle have to add to 180. So we can say 2x plus 3x plus 4x is equal to 180. So that'll be 9x equals 180. And when we divide by 9, we'll get x equals 20. So subbing the 20 back in, we get that this angle is really 40. This angle is really 80. And 3 times 20 will give us 60 for that big angle. Well, because these were congruent, it was being bisected, we know each of these is going to be 30. Notice I haven't even talked about or referred to any of the questions yet. Because what I would suggest to always do is just take the given information and work to see if you can get all the arcs. If you can get all the arcs, you can answer any possible question. Well, notice from each of our 30s, those are inscribed, so the angle they open up to should be double that. So this should be 60. This should be 60. Arc BC should be double the 40, so we get 80. And arc BA should be double the 80, so we get 160. Notice we now have all the arcs, so we should be able to answer any possible question they throw at us. I would suggest with these big circle problems, just take the given information, try and find the arcs. Then you can answer any question they want. So we want angle BAC. Well, notice we already found that. That's 40 degrees. We want arc BC. We already found that. That's 80 degrees. Angle CPT. Angle CPT is right here. That's formed by crisscrossing chords. So that's just going to be equal to 1/2 the arc it opens up to, which is the 60, plus the arc its vertical angle opens up to. Its vertical angle opens up to the 160. So that's going to be 1/2 times 220, or in other words, that's 110 degrees. Next one we want is angle PAT, which is this angle right here. Well, it opens up to arc CA. And it's an inscribed angle. Inscribed angles are half the arc it opens up to. CA is those two 60s put together, so 120, and half of 120 is just 60. And then the last one, angle T. So we just found this one was 60, by the way. So here's two ways you can find angle T. First way, it's an angle outside the circle, so it should be equal to 1/2 the outer arc minus the inner arc. Well, if you follow where T hits the circle, the outer arc would be that 160 minus the inner arc, which would be the 60. So this would be 1/2 of 100, or in other words, 50 degrees. So that's one way to find it. Another way, always use your triangles. We have a 110. The angle next to that should be its supplementary, so this would be 70. 70 and 60 is 130, so then this would have to be 50 by angles in a triangle. So just be on the lookout for those angles in a triangle. That can often help you out as well. All right, moving on to question 2, another big circle question. So we'll read through the given information, see what we can label, and we'll work to try and find all the arcs. Once we have all the arcs, then we'll look at the questions, because if you have all the arcs, you can answer any possible question they throw at you. So we've got circle O, that's meaning O is the center. We have diameter AD. Always be on the lookout for diameters. That's probably going to be helpful. So because AD is a diameter, we know AED is 180 degrees and ACD is going to be 180. So that's probably going to come into play, so just keep that in mind. We've got BCE, AD intersects B at F, you got a couple chords. AFB is 80 degrees. Okay, that's going to be helpful. So AFB we'll label as 80 here. And arc AC is 100. So we'll label that's 100. Well, we can get some other information here, because remember, we want to try and get all the arcs first. Because AD is a diameter, ACD has to add to 180. Because AC is 100, we know that this must be 80. Let's call ED X for a second. AD is an angle, the AD at AFC is an angle formed by crisscrossing chords. So we know that 80 should equal 1/2 times the 100 plus the X. Multiply both sides by 2, we'll get 160 equals 100 plus X. Subtract the 100 over, and you get 60 equals X. So let's take that X away, and we now know that this is 60. Remember, AD was a diameter, so that entire left side, DEA, has to equal 180. If we have 60 for ED, that means 180 minus 60 leaves us 120 for AE. We now have all our arcs. Now let's look at the questions that they ask, because if you have all your arcs, you can answer any question they throw at you. So angle BED. BED would be this angle right here. The vertex is on the circle, so it's inscribed. So it should be half the arc it opens up to. It is opening up to the 80-degree arc there, so half of that would just be 40. Angle BAF. BAF is this angle right here. It's also inscribed. Its vertex is on the circle. If we continue past F to D, it's opening up to this arc right here, which was half the circle, 180. So half of that would give us 90 for that angle. You also might just know that that's a tangent and a radius and a tangent always form a 90-degree angle. Arc ED, we've already found that. That was 60. Angle B is outside the circle. When you're outside the circle, it should be equal to 1/2 the big arc minus the little arc. Well, from B, the big arc it's opening up to, the one furthest away is the 120, and the smaller the inner arc is the 100. So that'll be a half of 20. So we still get 10 degrees. And then lastly, we have EDC, which is this angle here. It's an inscribed angle. It's opening up to this entire arc. Together, that is 220. An inscribed angle is half the arc it opens up to, so that would just give us 110. Now, an alternative way we could have gotten that angle is, notice that 60-degree arc, this inscribed angle opens up to it. So that would have to be 30. 40 and 30 gives you 70, meaning there's 110 left for that angle in the triangle. So a couple different ways that we could have gotten it. Still, a third way is you could have thought of those inscribed angles separately and thought of the one on the left as half the 120, so that's 60. The one on the right is half the 100, so that's 50, and put them together to get 110. So sometimes there's more than one way you can go about getting the things that they're asking for in these big circle problems. All right, so we got another big circle problem, circle O, so that means O is the center. BAD is equal to 40 degrees, so we'll label that in our picture. AE is 5 times the measure of ED, the arcs. So what we're going to do is we're going to label arc ED as X, and we'll label arc AE as 5X, because we know it's 5 times that. Now, something that's not explicitly told to us, but we need to recognize, since O is the center, that means that AD is a diameter, because it's passing through the center. And remember, diameters always be on the lookout for. That's going to help you out a lot. We know it's going to cut the circle in half, so each side of it is a 180. And the reason we need to recognize that here is, notice that bottom half now, AE and ED, those arcs, we had as 5X and X. Well, we know that those should add up to 180 now. Because it's half the circle. So that's 6X equals 180. Divide both sides by 6. 18 divided by 6 is 3, so X will be 30. So if we put the 30 back in, this will just be 30. 30 times 5 will give us 150. Well, we don't have all our arcs yet, so let's keep going. That 40-degree angle is an inscribed angle, so therefore the arc it opens up to should be double it, so we should get 80 for this one. And then let's use the fact that that AD is a diameter again, so the top half, the arc should add up to 180. If BD is 80, that leaves 100 for AB. Now that we have all our arcs, okay, now we'll look at the questions. So I did not even glance at the questions they asked for until we have found our arcs with the given information. So BD, already got it, 80 degrees. AE, already got it, 150 degrees. ACE is this angle outside the circle. Hopefully at this point we're comfortable when it's outside the circle like that. It's half the outer and inner arc subtracted. So we're going to have 1/2. Our outer arc that it's opening up to is the 150, minus the inner arc it's opening up to, which is the 80. So that's 1/2. If we subtract them, we get 70. And half of 70 will just give us 35 degrees. And then lastly, we have AED, which is this angle here. It is inscribed. AED hits the circle at D and A, so we're doing half of this arc. Together, the 100 and the 80 gives us 180, so half of that would just be 90 degrees. All right, in 4, they tell us we've got circle O. So notice, even though they don't explicitly state it, we know that AE is a diameter because it's passing through the center. So we know the top half is 180 degrees, the bottom half is 180. That'll probably come into play at some point. AB and BE are in the ratio of 2 to 1. So let's call AB 2X, BE would be X. Because we know that top half is equal to 180, We can do 2x plus x is equal to 180. That would give us 3x equals 180. We'll divide both sides by 3, and that will give us x equals 60. Sub that x back in, so we know that this arc then is 60, and this one is 120. Well, the bottom arc is just one single arc. We know that that has to be 180 because of the diameter. Note we have all of our arcs now. Now let's glance at the questions because we can answer any question they could throw at us now. AB, we already found it. It's 120. BAC is this angle right here. Its vertex is on the circle. Because the vertex is on the circle, it's inscribed. So it's half the arc it opens up to. It opens to the 60. So this is just 30. Angle C is outside the circle. So that should be half the big arc minus the small arc. The big one it opens up to is 120 minus the small, which is 60. So that's 1/2 times 60, or in other words, 30 degrees. And lastly, angle ABC. So probably the easiest way to find angle ABC is note triangle ABC. We've already got 30 and 30 for two of the angles, so we know they have to add to 180. So if we take those 30s away, that just gives us 120 for angle ABC. All right, one last page. We'll look at some a little bit quicker ones. So we've got a regular pentagon that is inscribed in a circle here. If you have congruent chords, okay, ED, DC, CB, BA, AE, those are all congruent chords. Congruent chords implies congruent arcs. So that means each of those arcs are the same. Well, there's 5 of those arcs. They must add to 360. So if you do 360 divided by 5, that'll tell us that each of these arcs is just 72 degrees. And that's the first thing they wanted to know. They wanted to know one of those arcs, CD. Well, then angle A is an inscribed angle, and it is opening up to arc EDCB. So inscribed angles are half the arc it opens up to. 72, 72, and 72 would give us 216. So it should be half of 216, or in other words, 108 degrees. All right, last one for this video starts or finishes how we started. In the warm-up, we saw crisscrossing chords, and we were working with the angle of crisscrossing chords. The angle of crisscrossing chords, so in this case 80, is equal to 1/2 the sum of the arc it opens up to and the arc its vertical angle opens up to. Note that 80 is not a central angle. There's nothing told to us about what the center of the circle is or the name of the circle, and it's not marked as the center, so we can't assume it's the center. So we'll just have 5x plus 2x plus 20. I think it's easiest to multiply both sides by 2 to start, so we get 160 equals, and if we combine like terms, that's 7x plus 20. Subtract the 20 over. That's 140 equals 7x. And divide both sides by 7, and we get x is 20. And that's what we were looking for part A. Well, arc AB is just 5 times that. So 5 times our 20 gives us 100 degrees for AB. And CD, we were just subbing in as well. We'll sub in the 20 for X. 2 times 20 is 40. 40 and 20 gives us 60. And you can even check that 80. If we add the 100 and the 60 together, you get 160, and half of that is 80. So that does, in fact, check out. That's it for this video. Have a great rest of your day.